About simplifying rational expressions, again, one of the purposes is to make sure we can handle all kinds of operations, simplifying, combining, and the like, in order to do a lot of the operations that we will do with rational functions, which we will do later. All right, so in this case, well, I know what you might be thinking. Well, usually when we learn operations, we do addition and subtraction first. However, when it comes to rational expressions, we do the multiplication first, and then we do the multiplication division, and then we do the addition subtraction afterwards. Well, and the reason to that is because addition and subtraction are a little more involved than multiplying or dividing fractions. All right, so we have polynomial over polynomial times another polynomial over polynomial, and no, don't do this. We cannot cancel terms like this. That's not how we do. All right, so instead, what do we have to do? We have to factor every single polynomial on the, and I'm going to do that on the side with all the techniques that we learned in the previous couple of lectures. So we will. Okay, let me write the first one. 2x squared plus 12x minus 32. All right. So, any ideas how to factor this trinomial here?
The diamond method?
The diamond method. Well, what's the first thing we try every time we have a trinomial? Corey?
Factor out 2.
Yes.
I was going to say multiply 2 by 32.
That would be like the diamond method, right? But in this case, so how about we factor the GCF? That's the first thing you want to do, because check this out. That's going to leave us with x squared plus 6x minus, is that a 16? And we can easily factor this one out using the double bubble method rather than going through the diamond method, or even the other method I showed you. What was that? The slip and slide method. And well, so this will be equal to, let me see how much space we have. Okay. 2 times factors of negative 16 that add up to, what's that? 6? What are those two numbers? Negative 4 plus 4. Okay, so negative 4 and positive 4, well, multiplied, they give us a negative 16. However, added together, they don't give us a positive 6.
Negative 2 and 8.
2 and 8. So it's around 2 and 8, right? 2 and 8. However, positive 8 and negative 2, because we want the product to be negative and also the addition to be a positive result. All right. Let's go with the denominator of that first fraction. X squared plus 16x plus 64. All right. Any ideas as to how to factor that trinomial?
You're going to do the diamond method for this one.
The diamond method, well,
It would be 8 and 8.
8 and 8. Well, so actually, okay, factors of 64. So it's not the diamond method, just the double bubble method. The diamond method, we use it when we have a leading coefficient different than 1, like the first case. However, when we cannot factor it out, like in this case, we could factor it out, we didn't need the diamond method. Here it's the same thing. And then plus 4, and then plus 4. And I know what you might be thinking. Write this x squared plus 4 times x squared plus 4 squared. However, it would be better if we leave it like this. You'll see why. All right, now let me go with the numerator of the second fraction, x squared plus 10x minus 16. And well, so in this case, how about factors of what's that? Negative 16 that add up to 10.
2 and 8.
2 and 8. So it looks like 2 and 8. Again, it's going to work. So x plus 2, x plus 8. All right.
Plus 16.
Plus 16. Is that a plus? Oh, yeah, that's a plus 16. My bad. Yep. And one more. Let's do the denominator of the rational right here. of the second rational, that is x squared minus 3x minus 10. So again, that's a good one for the double bubble method. And what are factors of negative 10 that add up to negative 3? Negative 5 and 2 looks like that is correct. Negative 5 and plus 2. All right. So what are we going to do? Okay, let me highlight color code. Well, let me highlight the numerator of the first fraction with the result, right? So we can see the relation. Let me highlight the denominator with green, which is the result of factoring the trinomial in green. Let me highlight the second numerator with blue to relate it to what we did in blue. And lastly, let me highlight this with red so you can relate with what we did here as well. So let's just write down our results. Okay, we use the same colors. All right. Okay, so I will replace this 2x squared plus 12x minus 32 with the result that in factor form, that is 2 times the quantity x minus 2 times x plus 8. And I'm going to divide this by the quantity in green, that is x plus 4 times itself x plus 4. Yes.
Going back to the second one,
Uh-huh.
it's supposed to be 64, so it might be
Yes, it's not 4 and 4, right? What would be the result then? 8 and 8, right? So plus 8 and plus 8. Yep. So let me change that to 2. Plus 8 and plus 8. And then times. All right, let me use blue this time. That's going to be x plus 2, x plus 8. And divide that by the quantity in red, which is x minus 5, x plus 2. And well, now that we have everything in factor form, here is the part where we will divide out all the common factors, all right? So let me use another color, a nice color that contrasts, hopefully. Well, let me use this black. Why not? Okay. So that x minus 2, check this out. This x minus 2 with, no, that's about it. We can't do anything about it. No, that's going to remain there. We don't have any x minus 2's in the denominator. However, we have this x plus 8 with that x plus 8, and then another x plus 8 with another x plus 8 that divide out. And then we have this x plus 2 right here with the x plus 2 in the denominator, and well, nothing else reduces even further. So in this case, what is that going to be? That's going to be 2 times the quantity x minus 2, and then the whole thing divided by x minus 5. And that's our final answer. Right? So here again, we're using, well, mostly the same, what's it called, the factoring of trinomials for the next exercise, which will be somewhat similar to what we got in the previous exercise. However, the difference here is we have a division, not a product of the two rational expressions. All right. For the division, we need to do something else first. And maybe you have heard about the KFC rule. Have you ever heard of it? No? Okay, KFC rule doesn't have anything to do with chicken, by the way. What does that mean? Well, that means keep, flip, change. All right? Keep, flip, change. What about it? Well, we are going to keep the first fraction, y squared minus 9, to y squared minus y minus 15. We will flip the second fraction to y squared plus y minus 10, 3y squared plus 10, y plus 3, and change the division symbol into a multiplication symbol. So that's the KFC rule in action. All right. All right, let's have a look at this one. So what do we have? Y squared minus 9. That's the numerator on the first fraction. So how do we factor that y squared minus 9? What's the name of the form, first of all?
Perfect square.
Hmm?
Perfect square.
Perfect square, but what about perfect square? Need to be more specific?
Oh, minus.
Uh-huh. So in general,
Y minus 9, Y plus 9.
oh yeah, no, that's correct, but I mean the name of the form in general. That has to do with squares, correct? Difference of squares, right? So we factor the difference of squares by writing whatever quantity squared equals the first term, and the quantity, whatever quantity whose squared equals to 9. In other words, this will be y and this will be 3. And all we do is just write this as a product of conjugate binomials. That's y3, y3, 1 plus and 1 minus, or 1 minus and 1 plus. You name it, either way. So that's the first one. What about the second part? So for the second part, we want to do, okay, so that's a 2y squared minus y minus 15. And that's the fraction in the denominator of the first fraction. How do we factor that trinomial? Which method? Diamond method. Okay, diamond method. Let's do the diamond method. Let me do it small because I'm afraid I'm going to run out of space. Okay, let me see if I can. Like this. Okay. So that'll be, okay, multiply 2 times negative 15. That's negative 30. Bring down the middle coefficient. And we need factors of negative 30 that add up to, what's that, negative 1. So what are those factors?
-6 and 5.
Negative 6 and 5, which we're going to use to break up the middle term, negative 6y plus 5y. So let me write it as a 4-term polynomial, 2y squared minus 6y plus 5y minus 15. And well, when we have 4 terms, we do the grouping, find the GCF of every single group. That is going to be 2y times, what's that, y minus 3 plus 5 times y minus 3. And again, do you see this last GCF? Y minus 3, y minus 3. That's going to give us the quantity y minus 3 times 2y plus 5, or you can write them in the other order, 2y plus 5 times y minus 3, either way. So we got the second one, that's the denominator of the first fraction. Let's do the third one, the numerator of the second fraction. That'll be, okay, so that's a 2y squared plus y minus 10. How do we factor this trinomial? Which method did we use? Diamond method. Okay, so let's do the diamond method. That is 2 times negative 10, that's negative 20, and that's a 1. Factors of negative 20 that add up to 1. What are those factors? Negative 4 and 5. Okay, negative 4 and 5. That means negative 4y and 5y. That's what we do these two special numbers, right? So we split it into 2 terms, write it as 4 terms, 2y squared minus 4y plus 5y minus 10. And then from here, again, let's do the grouping. And that's going to be 2y times y minus 2 plus 5 times y minus 2. And do you see again that greatest common factor? All right, so that is, oops, not this one, not like this, rather, y minus 2, and that's going to be 2y plus 4, or rather, let me do the y minus 2 first, times 2y plus 5. In the same way, all right? And lastly, oh, barely have enough space to factor the last one, the denominator of the second fraction. That'll be, what's that? 3y squared plus 10y plus 3. So, diamond method again, 3 times 3, that's 9, and 10. What factors of 10 add up to 10? I mean, what factors of 9 rather add up to 10? 9 and 1. And let me do, which one should I write first? Well, either way, I guess. So 9y, 1y, which is just y. And well, so that'll be 3y squared plus 9y plus y plus 3, right? And then from here, grouping again. That's going to give us 3y times y plus 3. And then notice the y plus 3. So for the y plus 3, there's really nothing to factor out. However, and we've seen this before when we first covered how to factor trinomials. So you might want to think of this as having parentheses, have a plus 1 times parentheses y plus 3. That way you can see the GCF, which is y plus 3, which multiplies that by 3y plus 1. So we have everything in factor form right now. So now let's see. Let's go back and write all this fraction. Okay, so that's what? Y plus 3 times y minus 3 divided by, okay, the result of the second factoring, y plus 3 times 2y plus 5. So that's the first fraction. And then the second fraction will be, okay, the numerator, that's a y minus 2 times 2y plus 5. And lastly, that's a y plus 3, 3y plus 1. So that's our original problem in fully factor form. Question?
On the bottom of the left fraction, is it y plus 3 or y minus 3?
Y minus 3, which one? This one right here?
The left one.
That should be minus 3. Yeah, that's a minus 3. That's correct. Oh, yes, it's minus 3. All right? Yeah, thank you. And here is where we divide out the common factors. Again, we don't divide out terms, but factors. So let's see. We have a y plus 3 with another y plus 3. Y minus 3 with y minus 3. Is there anything else to factor out, to divide out rather? 2y plus 5. 2y plus 5 and 2y plus 5. And that's going to leave us only with y minus 2 in the numerator divided by 3y plus 1 in the denominator. And that's final answer. All right? All right, let's see. Let's see what's next. Well, so we already did one example of a multiplication, one example of a division. I mean, of course, we could do a lot more of this, but do you see how these take a long time? So let's see. So let's move on to the next topic. Okay, I mean, in the same set of exercises, now we're going to do another operation, that is addition and subtraction. All right, let's see. 3/5 plus 7 plus 19/5. True or false?
False.
Oh, actually, well, that's supposed to be a 22 rather. True or false?
False.
False. Why is that false, by the way? What's wrong with that operation?
The LCM,
Hmm?
the denominator.
The denominator, what about it?
It should be 5
Should be 5. Why should it be 5?
because on both sides the denominator is 5, so we
Mhm.
multiply it by 1, so the denominator should be 5.
Mm-hmm.
So they multiply
like the denominator will
So the 2, okay, well, let's see. So we should write a 5 instead here, right? So, and that's because, well, when we are combining fractions together, what we do is keep the same denominator and only do the operations implied with the quantities in the numerator. Same with, say, I don't know, 17s minus 5, or rather minus 8 over 17. Well, keep the denominator 17 and just do the operation 7 minus 8, which is a negative number in this case, right? So the same idea is going to be taken for operations with fractions containing variables. So in this case, if it works for you, highlight the denominator so you can see which one is going to be the quantity that we keep, that is the x minus 2, and we'll simply go about 5 plus 3, which adds up to 8 over x minus 2, right? Very simple combination. I mean, treat it the same way as if we had these operations with simply numbers, all right? Now, what about the next one? All right, let's see. Letter D. Notice how the denominator has the same, how the fractions, both of them, have the same denominator. And in this case, well, so we can just go about performing the operation implied with the quantities in the numerator. And let's go ahead and do that. That is going to be, okay, open or draw a division bar, x plus 7 in the denominator, and just go like x squared plus 7x. All right? And it seems like we're essentially done with this one. However, that can be further reduced to lowest terms. Okay, how about we factor out an x from the numerator? That's going to leave us with x plus 7 over the quantity x plus 7. And in the same way we did before with the cancellation of factors, we can divide out the x plus 7s, and that's going to leave us with simply the quantity x. All right? I'll let you try letter E on your board. So, okay, so again, we have the same denominator, that is n squared minus 1, n squared minus 1. That means we can just go ahead and write one single fraction with the common denominator, n squared minus 1, and simply do the operations implied in the numerator, that is 2n squared minus 2n. However, well, even though that looks like a final answer, if you put this on MyMathLab, anything like this, it's not going to take it correct, unfortunately. So we need to further simplify and careful. I see some of you doing canceling these terms like this. No, we don't cancel terms. We just cancel factors. So the way about this is to factor the GCF in the numerator, and that's going to leave us with what? N minus 1. And in the denominator, we have a quantity squared minus another quantity squared, which is n plus 1 times n minus 1. Only then we will be able to cancel out factors, which leaves us with the quantity, what is that? 2n over n plus 1. All right? That's our final answer. Okay, let's have a look at letter F, and let's see. Letter F, same situation. Letter F, how about highlight the denominators, because they seem in this case like they're the same denominator. That means we can go ahead and do, in this case I'm going to do a big bar, because I'm going to have a lot of terms in the numerator. All right, so that means x plus 1 in the denominator. Now, what would we write in the numerator? You know what? Actually, how about you try it too? Okay, so for this subtraction right here, notice we have more than one term in each group, in each fraction. Okay, write the implied operation. So 9x plus 1 minus 6x minus 2. I claim there is a mistake in here. Well, what's the error here? Parentheses, right? Because this minus right here technically affects both the 6x and the negative 2. So, and you don't want to do everything in one shot unless you feel confident about it. That's fine. However, in the meantime, take one step to write the whole thing down, and then just go equals to 9x plus 1 minus 6x minus minus equals to plus 2, right? Which would divided by x plus 1. And then from here, 9x minus 6x, that equals to 3x, 1 plus 2 equals to 3, and divide that by x plus 1. All right? And anything else you think we can do? Do we call it a day for this one? Or factor? What do we factor? The 3. Okay, factor the 3 in the numerator, x plus 1 over x plus 1. Divide out the x plus 1's. Final answer, 3. We combine fractions together, fractions containing the same denominator. Now we're going to do other fractions, well, other kinds of exercises in which the denominator is not going to be the same. All right, okay, the question here is true or false? That's 10 over 8. False. All right, what are we supposed to do in this case?
Have to multiply the denominators to find the greatest common.
To find the greatest common denominator, right? So in this case, we don't have a common denominator. One denominator is a 2, and another denominator is a 4. So we want to write, well, the fraction with the smallest value. Well, if the second denominator is a multiple of the first one, well, because this is not going to work all the time. So this is what we need to do. We need to write what we usually call equivalent fractions. What are those equivalent fractions? Well, let me write something on the side. Okay. Do you agree that this is okay, the number 1/2? Okay, do you have any ideas about another way to write the number 1/2? What is that? 5 over 10. All right, 5 over 10. Another way?
3/4.
2/4, right? Any other ways?
3/6.
Oh yes, 3 over 6, right? How about 36 over 72? How about, I don't know, 500 over 1,000? All these fractions are equivalent fractions. They represent the same value, but they are expressed in a different way. How about, for instance, 2/3? Any other way to write 2/3?
4/6.
4 over 6, all right? 4 over 6, all right? Any other way? 8 over 12, okay, let's see, 8 over 12. Yep, divide both by 4, we get 2/3, yes. What about simply, 20 over 30? All right. Now, what is that going to depend on? It's going to depend on our needs. For instance, we want to write the number 7/2 in a way, in an equivalent form, so that the denominator looks like a number 4. All right. Now, this is what we're going to do. Okay, let me rewrite the whole thing, and I'm going to leave some space right here so we can put the missing factor. 7/2 space plus 3/4. And in this case, what are we going to do? We are going to multiply numerator and denominator by that number that turns these two into the same denominator as the second fraction, which in this case is 2. All right? And again, why can we do this? Because, well, if we multiply by 2 and then we divide by 2, essentially we're multiplying by 1, right? Does the result of an expression change when we multiply by 1? No. Okay? Here we multiply across. 7 times 2, that equals to 14. 2 times 2 equals to 4 plus 3. over 4. And now we can combine the 4's together. 4 plus 4. No, not 4 plus 4. Just bring down the 4. 14 plus 3, that's a 17. And that's 17 fourths. All right? And what about the next exercise? Oh, in this case, well, let's compare letter G with letter H. So letter G. The largest of the denominators was a multiple of the smallest of the denominators. So that's why we're required to multiply by missing factors only on one fraction. However, for letter H, notice the two denominators, the smallest of them is a number 3 and the largest is 7. However, in this case, 7 is not a multiple of 3. What are we going to do in this case? Well, so number 1, whenever that's the case, 5/3 minus 9 over 7, multiply by 7, divide by 7, multiply by 3, multiply by 3. In other words, what we're doing is multiplying by the missing factors so that they all have the same factor, the same denominators. Multiply across each. 5 times 7, that's 35 over 21. Minus 9 times 3, that's a 27 over 21. All right? And that reduces to, well, in this case, keep the denominator, the 21, and just do the operation implied in the numerators. All right, that's 35 minus 7, and I believe that's a 20. That's a 21, right? That's an 8 over 21. All right. So that's how we combine fractions together whenever these don't have the same denominator. And we're going to use the same idea to simplify those containing variables like letter I. 4 divided by x plus 2 minus 5 divided by x minus 7. What is that going to be? Well, so number 1, 4 x plus 2 divided by x plus 2. I'm going to leave some space here, minus 5 over x minus 7. And here what we want to observe, how these two denominators, x plus 2 and x minus 7, they are not the same. And no, we're not allowed to add, say, plus 9 to turn this into x plus 2. No, that's not how we do. We don't add. We cannot just add numbers, numerator and denominator. We can multiply to make them equivalent fractions instead. So notice the first fraction has a denominator x plus 2 that the second doesn't have. How about we multiply the second fraction by x plus 2 and divide by x minus 2. Now the second fraction has an x minus 7 denominator that the first one doesn't have. That's x minus 7, multiply by x minus 7, divide by x minus 7. So,
is that supposed to be x plus 2?
Yes, plus. I'm going to put parentheses. Now, here is the thing. This is what we're going to do. Let's write an equal big bar. Now that we have, notice we have the same denominator, x plus 2, x minus 7, even though in the second fraction the factors are reversed. But again, it's the same thing. So that's going to be x plus 2 times x minus 7. And in the numerator, just go about the operations implied. Now, check this out. Here we have a multiplication, 4 times the parentheses minus 5 times the parentheses. Let's go. If you can do everything in your head, that's fine. However, I would recommend you would do that. So 4 times x minus 7 minus 5 times x plus 2. And well, I guess from here, you know the drill. Distribute the 4, distribute the negative 5 along with the sign. And that's going to give us what? That's next 4x minus 7 minus 5x minus 10. Very careful with the signs. And then the whole thing divided by, keep writing the denominator, the common denominator of x plus 2.
Would that be 28?
And which one? Oh, yeah, 28. 28. Yep. So 4x minus 5x, that equals to negative x. And negative 28 minus 10, is that a negative 38? Which divides by x plus 2 times x minus 7. All right. At this point, again, we are going to go back to consider the possibility of simplifying these to those terms. However, I don't think there's much to do other than factoring out the greatest common factor in the numerator, which is the negative sign. That's a negative 1 times x plus 38 divided by x plus 2 times x minus 7. And well, if you don't want to write this negative 1 in front of the parentheses, just to write it in front of the overall fraction, x plus 2 times x minus 7. And that will be our final answer here. All right. So let's see what do we have next over here. All right, the next one. Okay, so for the next one, we may need to work a little bit more about it because, well, notice in the previous exercise we have just linear factors. I mean, there were nothing else to figure out, or to factor out rather. In this case, the rule here, and you might want to write it down. So make sure to factor all the denominators. All right? Factor all denominators. Notice the quantity in the denominator, x squared minus 1. I don't think it's not in factor form, but we know the form for that one. What is it? So x plus 1 times x minus 1. It's a difference of squares, 1, plus 3 times the quantity, x plus 1. Now, here is the question here is, do we have the same denominator? Unfortunately not. Now, here is the thing. Both denominators here have an x plus 1, so we don't need to fix any of the fractions with an x plus 1 because it's pretty much ready. However, what about that x minus 1 that it's in the first denominator, but it's not in the second denominator? Well, so we need in this case to make sure the second fraction has also a factor of an x minus 1. We do that by multiplying numerator and denominator by x minus 1. All right, that'll be, okay, big fraction. Big fraction, that's x plus 1, x minus 1. And then in this case, we just 1 plus 3 times the parentheses, 3 times x minus 1. And the rest of this just, so once we get to writing one single fraction with a common denominator, just distribute, just essentially just focus on the operations in the numerator. That's going to be, so 1 minus 3, that equals to 3x plus, no, minus 2, right? Minus 2 and divided by x plus 1 times x minus 1. Now let's see if we can reduce this one to lowest terms. Well, from the numerator 3x minus 2, I don't think there's anything to factor any further. If these were, for instance, a 3, we can factor out a 3 and factor out the x minus 1's factors. However, it's not the case. So in this case, forgot the x plus 1, x minus 1. So we can call it for this result right here. All right. Letter K. So number one, we have two different denominators, x squared minus 3x plus 2, and the other denominator is x squared minus x minus 2. And no, we are not allowed to fix and add numbers to make them look the same. No, that's not how it works. What we need to do, and again, we have this note at the very top, we need to make sure to factor all denominators so we can see what factors are there and what factors are missing. So that'll be okay. For the denominator, notice the trinomial has a coefficient of 1. Just double bubble it. That's all it is. That is factors of 2 that add up to negative 3. What are those two factors? Negative 1 and negative 2. Okay, everything below 1. Minus, okay, what are factors of negative 2 that add up to negative 1? Negative 2 and plus 1. All right, and that everything under the 1. All right, if it worked for you, because notice how this time we have a bunch of factors. So what you might want to try in this case is highlight them. Okay, let's highlight them. Highlight the x minus 1. Do we have another x minus 1? No, right? Can we use a different color then? We use green for x minus 2. Oh, we have another x minus 2 here. All right. Oh, by the way, I think I'm gonna make some space in here to multiply numerator and denominator by missing factors. And let me use red to highlight the x plus 1. This way you can see the nature of the different factors that we have over here now. Okay, so the greatest common factor here will be a denominator that contains a yellow, a green, and a red, right? Because those are all three different ones. So, well, here we only have the yellow one and the green one. What are we missing here? Think of colors.
Red.
Okay, here we have green and red. What are we missing? Green, yellow, I mean, right? Yellow. So let's put the missing ones. The yellow one, the red one in the first. In the first fraction, that is x plus 1, x plus 1, and let me highlight it so you can see it. And let's multiply numerator by yellow on the second fraction. And I will keep highlighting. All right, one thing to observe here now is how we have the same denominator. Now we have created two equivalent fractions, like multiplying by 4 dividing by 4. But in this case, we're multiplying by convenient factors that give us the common denominator comprised by the three different factors. All right, let's go for it. So that'll be big bar, yellow, which is x minus 1, green, which is x minus 2, and red, which is x plus 1. All right, what are we going to be left with here? The operations implied. 1 times x minus 1, that's the quantity x. I mean, x plus 1, it's a quantity x plus 1. And minus 1 times, careful with the minus. Whenever you have a minus, always keep the parentheses. And that's because this minus will affect everything inside of the parentheses, and you need to change those signs in accordance with the change of signs, right? So that's going to be then x plus 1 minus x plus 1 divided by x minus 1, x minus 2, x plus 1. So again, what I know what you might be thinking, and I saw some of you doing this, and let me talk about it. Some of you cancel this x minus 1 with that the x plus 1 with the x plus 1, and the x minus 1 with the x minus 1. Let me explain why that is not correct. So notice what's the operation implied between all these three in the denominator? Multiplication. We agree it's a multiplication. It's a product between three factors, 1, 2, and 3. However, what is the operation implied between this group of parentheses and that other group of parentheses? So here is we have a problem when we divide this out this way. So check this out. That's going to take us back to the PEMDAS mnemonic that I'm pretty sure sorry, pretty sure you've seen it before, right? PEMDAS. And this PEMDAS, it's an acronym or a mnemonic to describe the order of operations or the hierarchy of operations. P, which stands for parentheses, that's one whole level, all right? That's one whole level. And then another level of operations, it's the exponents. And then the next level of operations is, well, let me use a different color to box them. Yes. And then the next order of operation, that one includes both the multiplication and the division, and that's because really multiplication and division are the same, or rather the division is exactly the same as the multiplication, but we're multiplying by the reciprocal of some number. That's what the division is. And lastly, another order of operations is the addition and the subtraction. And well, the subtraction is really the same as the addition because we're adding a negative number. That's all we're doing, right? And well, you might want to label these orders as level 1, level 2, level 3, and level 4. So when we are trying to cancel this out, like this and like that, so we are combining two different levels of operation. So we're combining level 1 with level 2. That's the reason why this is not correct. And actually, if you give a value to the letter X, and if you try to do that, well, you will find two totally different values. All right? So instead, well, let's combine the like terms in the numerator. That's going to actually cancel the excess, and that's a 1 plus 1, which equals to 2, x minus 1, x minus 2, times x plus 1. And that's our final answer here. And notice there's nothing else to divide out, to cancel out, because in the numerator we just ended up with a constant value. That's 2 and 1, 2, 3 factors. There's no, say, an x minus 1, an x minus 2, or an x plus 1, 2 to divide it with. All right? And that's our final answer to this one.
What about the subtraction symbol between the x plus 1 and the x plus 1?
Which one?
When you cancel out the x's, the other one out.
So x minus x, they cancel out.
Oh, okay.
That's like, that's 0. Yep. And 1 plus 1 equals to 2.
Never mind.
Yep. No, you're good. You're good. All right. However, in this case, well, after factoring this, notice how that we only have 1x plus 8. Here we have 2x plus 8. So we need to have the same number of factors. If this denominator has 2 of them, make sure to have 2 on the other one as well. Right? Now, did you notice this x minus 8 is missing in the second fraction? And now that we have the same denominator, let's see, and big fraction, x plus 8 times itself x plus 8 times x minus 8. And in the numerator, let's do the operations implied. That's x times the quantity x plus 8 minus 1 times the quantity x minus 8. But don't disregard these parentheses here. So, again, don't cancel out terms. Actually, in a way, ignore the denominator, but again, keep writing it. You need to keep writing it. And that's going to be, okay, distributive property, distribute x, distribute the negative sign. And that equals to x squared plus 8x minus x plus 8. All right, careful with this one. And the denominator just remains the same, x plus 8, x minus 8, another x plus 8 rather, times x minus 8. Combining like terms in the numerator, that's going to leave us with the quantity x squared plus 7x plus 8 and divided by x plus 8, x plus 8, x minus 8. Now, this looks like a final answer, and well, except for that trinomial in the numerator. So in this case, we need to find a way. Hopefully it's factorable and then divide it out with one of the factors. However, in this case, trying to use the double bubble method in the numerator, are there factors of 8 that add up to 7? So 8 times 1, that's 9, not 7. 4 times 2, that's 4 plus 2 equals to 6. No, it's not gonna work, right? So that's final answer, right?